But yeah, today I'm very excited to be here to talk about some of our data science challenges and areas that we operate in at Blizzard. And I'm going to first start with do a quick introduction. Since many of you know Blizzard, and for those that don't know, like Blizzard has been in the business of making epic entertainment experiences, or games in this case, for the past 25 years. Some of our flagship games like World of Warcraft and Starcraft and a couple of other games are quite popular. And a couple of quick highlights from the recent past. World of Warcraft, which is our MMO game, massively multiplayer online role-playing game, has had over 10 million subscribers at one point, and it's still going strong. Hearthstone, our collectible card game, it's available on PC, mobile, tablets, and we have had over 40 million registered users. And our newest game, this is Blizzard's first shooter, Overwatch, hit the market back in late May and quickly got to 15 million players, and it's continuing to grow. So we have a lot of data, as you can see, from all these users, all these players, and the games that they play in that generate so many events. Blizzard also is a company with a strong culture. This image actually is in front of our building in our headquarters. And this is an orc statue, orc from World of Warcraft, and around it are all our core values listed. And Blizzard lives and breathes our core values. And the most prominent among them, I would say, is this thing called gameplay first. So we care a lot about how our players experience the game, and we are constantly trying to iterate and trying to improve our games. And this is very important for us because our main focus areas, there are 3 of those, but we spend a lot of time, I would say 80% of our time in the area of game design. And to give you a description on what type of problems may be involved in the game design space, these could be matchmaking problems where you're trying to match teams of equal skill with other teams of similar skill. It could be about feature balance, about a certain feature within a game and the experience that our players are having. And it could also be about what type of players we have, how do they consume our games, what are the experiences like, can we segment them out. So these are the type of problems that we work with. The other areas, we do work in business strategy and operations. These are more run-of-the-mill type of work where we are focused on improving our acquisition, retention, and win-back. This would be very common to all the companies that operate this type of business with subscribers and free-to-play models. And then the last area that we have started doing some work on is personalized game experiences. We don't have anything out yet in this area, but something we are investing and looking towards releasing some services in the near future. So for this talk, I'm going to focus just on the game design area and pick a couple of problems and go through them and sort of share about like how we dealt with them and what are the areas we are looking to improve. And specifically, I would focus on these 2 topics. The first one is matchmaking for Heroes of the Storm. And the second one is for Hearthstone, how we estimate our meta strategies. So let me jump into Heroes. So again, real quick, like who has played Heroes here? Okay, not very many. So it's a 5v5 MOBA game similar to League of Legends and Dota 2 that are out there that are quite popular. So each player controls a character, and then you have a team of 5 playing against another team of 5 in a given map, trying to get some objectives and trying to defeat the other team. So for the purpose of this talk, we have a bunch of game modes within Heroes where you can queue up into all of these. The area where matchmaking plays into is a factor is just these 4 modes, quick match and a couple of other modes. And the main difference between quick match and the others is in quick match, you pre-select your hero and then join a queue. Whereas in the other games, you actually get into a game and then pick your heroes. So the one thing to keep in mind is, like, although I'm talking about matchmaking here from a data science perspective, there are a lot of teams involved in matchmaking. It's a big investment for Blizzard, and we have game design teams, engineering teams, production, tooling, all of the community. All of these teams need to come together to produce a good matchmaking service. So let me talk about real quick about the matchmaking flow, because this is useful for our discussion here. So in Heroes, players first come in. They can optionally form groups, and for a quick match, they will have to pick heroes that they want to play in. For other modes, they don't have to. And then players enter the queue, and then the matchmaker assembles teams. And then we have a notion for match quality, like does it surpass our minimum acceptable level? We check for that. And then if not, we go back and try to find better teams. And once we find a good team of acceptable quality, we kick off the match. And then post-match, there are ratings that are updated. Right now, Heroes represents a player's skill as a matchmaking rating and an uncertainty that's associated with that matchmaking rating, typical for many of the games in the space. So I'll be focusing on first on this area, which is, we call this the match builder. This is the component, logical component that assembles the teams and later on evaluates match quality. And so like I said, it deals with the problem of forming teams. So we went through, since we have different game modes, it works slightly differently for different game modes. Like I said, for a quick match, you have to pre-select the heroes, and for the other modes, like the heroes are not pre-selected. And then we went through a couple of iterations of the match builder, which is basically doing a lot of searching, trying to find similar teams. I'll go through those two iterations. The first one we call internally as a hill climber, because it has some similarities to hill climbing. And then the other one, which we call pruning combiner. So just real quick, from a conceptual point of view, like what the hill climber does essentially is it takes players, puts them into batches of manageable sizes, and then it sorts them by their matchmaking rating, by their skill, and then it comes up with an initial state, which is pretty much a random selection, but for checking a few rules. And then it goes through this hill climber stage where it's trying to swap team members to see if it can improve the utility of the hill climber. And also along the way, it applies some game rules. And then I'll define this utility in a little bit, but if it's going to check at each iteration whether it has improved the utility of a game, and only accept swaps that contribute to that utility improvement. And then go through a bunch of iterations, and then you arrive at a final stage. And then you check the utility that you're producing for each of those matchups. Does it meet your quality bar? Yes. Kick off the game. No. Put them back in the queue and rinse and repeat. And some of the things, factors that go into this utility computation are things that you would normally expect, like the difference in skill between the teams, the difference in uncertainties between the teams, within teams. Like there are several versions of these factors, and how spread the skill is within a given team, how long are groups waiting in a given point of time, what is the latency to game sides, what are the party sizes, things like that. So you can tag along a whole bunch of these factors. For the most part, we feel like this works well for 1v1 type of matchups, but as you introduce teams and introduce all these factors into a utility function, it gets blown out and some unforeseen things happen. So I'm going to talk about some pros and cons of it. Obviously, this solution is super scalable because you can do it. You can tag along different factors to the utility function. You can parallelize some aspects of this, so it's fairly scalable. And you can time cap it, which is good for a player experience in terms of wait time. You can say, I'm going to run these iterations for a minute or 6 minutes or 5 minutes, and then I'm going to absolutely kick off the games that get formed. So that's time bound. And also, you can tag along more and more of these factors later on into the utility function if you feel they are important. But the thing where it fails is ensuring that the match that it comes up with is of good quality. And the reason is because we have all these factors that are about latency, that are about wait times, and all of these other things that are important for forming a game, but don't necessarily describe the quality of a game really well. And we also noticed that because of these other factors, the experience for really high skill players was not as good. It was generally quite poor. So we went through a different iteration of this that we call pruning combiner. So the way this works, again, logically, is, well, we first sort players by priority, and here priority can be wait time, priority can be a different, determined in a different way. We also sort players by MMR, their skill, and then we pick, we build one game at a time and pick the highest priority party first. In this case, the yellow guy at the top. And then we build a game for that party. And in order to do that, we look for people that are similar to him in the skill spectrum, and then gather them. And we gather a bunch of them and keep them available to form this game, so they can't go form other games. And then we start building teams with those people that are nearby. And then we continue doing that. While this process is happening, we are also marking people that don't fit into these games anymore. That increases the speed of the search. And then once we fill the team, we look at, is this the right game? Does it meet our quality bar? And I'll talk about how we determine quality in a little bit. And in this case, it hasn't, so we go back a step and see if we can find someone else. And we check the match quality again. And in this case, we succeeded, and we're going to kick off the game. So that's loosely how the match builder works. And now I'm going to talk about what are the pros and cons that we see with this version. I think the pros clearly are, we start off with a much better initialization, and we have guarantees in terms of match quality, because all we are doing is finding people that are similar in skill and trying to form games there. And we also noticed from our experience that the play experience for high skill players, matchmaking experience, was really good with this version. Obviously, there are also some cons, in order to do one game at a time, we are keeping those players longer in the queue, so their wait time has increased by a little bit. But I think our players, from their feedback, what we have gotten is they wouldn't mind waiting for a little bit longer to get into good games. And it's also computationally expensive, but that's basically throwing more servers at it to solve this problem. So that's the match builder. And then we get to the stage where we are computing the match quality. And this is where we have gone through several iterations with the match builder and with the previous match builder and with the current match builder. So match quality deals with estimating how good a matchup is in a team setting. And it depends on what we have to quantify what good means. For the case right now, we determine good as the expected win probability should be close to 50%. And there are pros and cons of this definition. I'll talk about it towards the end of my talk. But this is what we use to determine if something is a good game or not. And we went through a couple of iterations of this as well. With the hill climber, we had the utility-based evaluation, and we had 2 more iterations with the pruning combiner that I'm going to talk about. So let's look at some of the results from the utility-based evaluation. And so what you're seeing here is a plot of expected win rate and real win rate. And this was in our old version of the matchmaker. The size of the dots indicate how many matches are formed in that space. So what we are noticing is, closer to 50%, yeah, this was doing reasonably well. But as the win rates spread out, our expected win rates and real win rates are far apart. And this naturally is a poor experience for the players. And the reason this was happening was because of all these, this assumption that we can just take everyone within a team and represent them with a given number and then predict the win probability just using that information. And it's not a good way to do it. So clearly we need to improve. So what we did next was we built a predictive model that takes into account various factors like different skills within the team, different experiences with play with the game, and we put them all together. And it only accepts a game if the prediction is within a acceptable threshold. And we chose for the first iteration of this the workhorse of these type of prediction models, logistic regression. We tried generalized linear models and other things, but this was enough. It mattered more what the features were than the model for this case. So the type of things that go into modeling this are the various MMRs within the teams and various uncertainties of those players, of the players' MMRs, and also these MMR spread, the skill spread within a team, across a team, the party sizes, and so on and so forth. And even though these are just a handful of factors, like there are different ways to represent them that would blow up the feature space a little bit. So now we looked at the results again to see how this did, and it was quite good. So we finally feel like we have something that we can deploy, where our expected and real win probabilities are lining up. So the players are going to have at least the expected experience here. However, there was still a problem with this. I'm going to show that in a little bit. So here the plot shows the expected win rate and also the real win rate by hero level, the experience players have with a particular hero. And remember, in quick match, one of our modes, you can pick your hero beforehand. So we have that information available. So we got that feedback that when players switch and play heroes that they don't have a lot of experience with, they're not exhibiting the same amount of skill that they were exhibiting with other heroes. So we naturally decided to address this problem and add more factors into our win probability. So we went ahead and added a whole bunch of other features like hero levels and experience with a selected hero and roles and stuff like that. And again, it's the same approach, but just improved our feature space by these factors. And now let's look at the results of this. And it's pretty much doing more or less the same thing. Expected and real are pretty much on par with each other. But let's look at the hero level plot and see what happened here. So now you can see that even though players are now playing different heroes with different experience levels, we are able to predict what their performance is going to be and able to put them in a proper match setting with this type of feature set. So that's in a nutshell like what we are doing in the matchmaking space with heroes. Obviously, we're still a long way away from truly getting to state-of-the-art type of the matchmaker. So some of the things that we are interested in developing in the future is something we call internally as performance-based MMR. And what this means is we don't want to just take into account at the end of a game whether someone won the game or lost the game. but we actually want to take in all the actions they do within a game. Like if you're playing a DPS character, you're doing a lot of damage, how do you stack up against others that are similar in performance and skill as you? We want to consider all those factors. We want to take your team composition into account. We want to build all of those in, and then factor in how MMR should be represented as a mapping of these performance events that get generated during the game. I think the good thing about this is even it's a team game, so even though personally someone might do well, your team may end up losing, and you might get penalized for that in the current setting. Whereas with these type of systems, we will be able to account for that and figure out how to adjust MMRs, as well as how to reward players properly for contributing to the game. The other area that we are also looking to research a little bit more is, right now we have this notion that if an expected win probability of 50%, if we can get that, that's a good game. But it could be possible that you could be put in games where 10 out of 20 times you stomp the other team, and the other 10 times the other team stomps you. And it's basically, in that case, I would say the experience was pretty poor in all 20 of those games, because it's not a balanced team game, even though the win rates at the end of those games would be 50%. So what we want to look at next is look at our survey data and figure out like what type of games do players value the most in terms of having a positive experience, and then try to incorporate those factors into the matchmaker. So in the future, we would not just be optimizing and trying to get to 50% win rate, but also accounting for all these other factors that contribute to a player's enjoyment. At the end of the day, that's what we care about. And the last area, which we are also starting to do some work on, is we want to provide feedback to the players based on their performance. So this is now outside the scope of the matchmaker. This is to help the players improve themselves or change their behavior in some way that could be productive to them. And again, the type of data that we will be using for this is all the in-game data that we have about events that happen within a game. And we can capture a lot of these events and then see where they are deviating from a proper strategy, and then can recommend to the players, suggest to the players how to improve their performance or how to collectively work with the team to improve themselves. So these are all areas that we are actively researching on, and hopefully we'll be able to share some of these results in the future. So I want to now switch to my second topic, which is Hearthstone meta strategy estimation. And here, let me again do a quick check. Who here has played Hearthstone? All right, I would say like 40% of the audience here. That's good. So for the others, like Hearthstone is a collectible card game. So it's online. It's 1v1, and you have a bunch of cards that you can create decks of, and you're trying to defeat your opponent. So you can play all these classes. We have 9 classes that are represented in Hearthstone. And all these, if you know about World of Warcraft, all these classes are derived from World of Warcraft. And so their abilities and spells have a lot of similarities to their counterparts in World of Warcraft. So you can choose to play as any of these classes. And then what you do is, in order to play, you need to construct what we call decks. And decks are a collection of cards, since it's a card game. And in this case, I'm showing an example of a deck for a class called Shaman. And this deck, Shaman, is a class that has a bunch of totem type cards that can buff each other up in certain ways. So this is a strategy where there are a lot of cards in this deck that are about buffing totems or gaining buff from totems. So we'll get into the strategy bit a little bit. And in terms of gameplay, in this case, the bottom character is you, mage, and you're playing against a warrior. And the way this gameplay works is each time you get mana crystals that you can spend to play cards to put minions on the board. So in this case, I don't know if I can point. No, I can't. In this case, like there is a minion on the board that's now you can use to attack the other hero or attack the other minions on your opponent's minions. And the goal is to get your opponent's health down to 0 before the opponent can kill you. So in order to do this effectively, there's a lot of decision making that goes into how to construct these decks, and that's what we are going to talk about. So let me give you a quick example here. So this is a deck called Aggro Hunter, and on the left you can see the cost of the cards, and you can see most of them are like 1 or 2 or 3 or 4. And the reason they are so low is because the strategy for this deck is to put out as many minions as possible early in the game, and then to do a lot of damage to the other player before he can put his minions on the board. Now let's look at a different strategy, different meta. We are now looking at Control Warrior. And Warrior is this guy who has armor and he's like a tank. And he has more expensive cards because his strategy is more about sustaining damage and then in the end playing big minions that can outright kill the other player. So there are between aggro and control deck, there is a spectrum of strategies that players can play, and that's what we are interested in, to understand how players are playing this and how is their experience. So for Hearthstone, we have these general design goals that all these meta strategies, they should be balanced. Nothing should be so overpowered that everyone is forced to play those type of strategies in order to win. So which means close to 50% win rates for these type of strategies with viable counter strategies available to counter them. And then as much as possible, all classes should be viable, which is not always the case depending on patch to patch and expansion to expansion. So given these design goals, now our goal is to understand how are players playing these strategies, how to estimate them. And the approach we are using for this is our standard clustering techniques. So in this case, depending on, we have used techniques like a mixture of Gaussians as well as other clustering techniques to do that. And the important thing is the data. Like we have the collection of decks and we have the match outcomes. So with these, we can come up with good ways to summarize what the meta is and how players are playing. So let me show you some results from this work. So, wow, I don't know if you can see this really well, but let me try to explain as much as possible. I didn't realize it would show up this badly here. So this area that I highlighted, what we have here is a bunch of names of the cards, and then here we have a number of cards that a particular strategy has. So each one of these is a cluster centroid, if you will, and it represents a single meta. And we can have several different clusters that all are about the same meta, because players can change those decks according to their liking, according to the cards they have. So we tend to typically have 2 to 3 flavors of a single meta in here. And then the designers can look at this and group them together, and we have a way to then look at summary statistics of this. So all of these represent our meta. So we have things like Aggro Warrior, we have things like Control Warrior, Dragon Warriors, stuff like that here. And then in this panel, what we have is the win rates for all of these metas. And I had to obscure the axes a little bit, but the range you're looking at is like 47 to 53% win rate. So most of these are already fairly well balanced, but you can sort of see which ones are high, index higher, which ones index lower. And then on the right, you have popularity by region. So you can sort of see, like, there's a certain style, certain styles that are popular in US, which are not popular in China, for instance, and vice versa. And that is important because when we consider these balance changes, we are balancing globally because anyone can play anywhere, and these are important things to consider. And at the bottom panel, what we have is crafting costs for each of these meta strategies, as well as a cluster quality metric that we built. And the crafting cost is important because it's a free-to-play game. We still want players to be able to construct low-cost decks that are viable and that can be played well. And the cluster quality metric is basically how many cards do you have in a given centroid, because centroids are obviously real numbers. And we have some crude thresholds that say, well, if you have up to 28 cards, then it's a pretty good match to a strong meta. If you have fewer, then it's a reasonable match. And if you have fewer than like 24 or something, then we would typically toss out those clusters because they're ambiguous. The other thing that we do is we also study how the meta evolves over time, because whenever we launch patches, we see all sorts of new strategies and then counter strategies and things like that. So we are quite cognizant of how they evolve over time. Sometimes we don't have to do anything to address the meta if the players themselves can come up with counter strategies. So here you see on the left side, meta popularity over time, and you can sort of see like warrior increasing and others decreasing in popularity. And if you look at a different time frame, you will see like totally different things. I'm going to skip the other two charts there and get to this. We also look at how these metas stack up against each other to make sure we have viable counter strategies. So you can see that almost every strategy has some type of counter strategy, and depending on a given time period, these become popular, more popular and less popular, and so on and so forth. And some future improvements that we want to do in this space is we also want to estimate the quality of the matchups that happen. Again, not necessarily depend on win rates. And we also want to be in a position to suggest what may be good balance changes if we see imbalance within these strategies. And then the last thing is for players, we want to recommend what type of decks they can build from the collection that they have, so that they're not going in completely blind on this. And I talked a lot about defining match quality, so I want to show some early results from Heroes, just to tease this a little bit. So here what we are seeing is we capture XP difference between teams over the course of a game, and then we came up with these like profiles of how the game progressed over time. So for instance, if you look at the green line, you can see that they were neck and neck for most of the game. Whereas if you look at the orange line, you can see that they were neck and neck for half the game, and then one team took off and won. And if you look at the blue one, which it was more of an underdog fight where the team that was behind suddenly came up and won the game. So these are all the things that we can capture from our data and then inform how our players are experiencing the game. And so just want to quickly summarize the talk and say, we have a bunch of focus areas, game design being our highest priority and has our most focus. We also are working on business strategy and operations, as well as some personalized experiences for our players. And today I gave a couple of examples on the game design space, specifically matchmaking on heroes and Hearthstone meta strategy estimation. So we're actually hiring. So if you guys are interested in these type of problems, if you want to contribute, come talk to me. Or we also have Shuo here. I don't know if he's right over there. He's going to be here for the rest of the conference, so you can talk to him as well. Thank you.
Thank the speaker.
Right. So
Can you repeat the question? Sorry for that.
Yeah. So let me paraphrase the question. So you're talking about, sometimes we can pick certain types of heroes that are, as a combination, they're not as effective as the heroes that the other team picked. And even though your skill-wise, you two are equally matched up, but because of the hero choices, there's an imbalance. How to address that, right? So the thing we do here is twofold. One is we force certain rules where we know that certain matchups are clearly bad, so we don't allow that. And then we know that certain matchups are suboptimal, but you can still pull it off. And the way we do that is for our quick match, we take those factors into account. And so there are features within our prediction model that looks at what combination of heroes are you playing, and it can capture whether that combination is strong or weak or reasonably balanced. And so we address that from that perspective.
Yeah.
So normally plays multiple games, companies that like Hearthstone and Heroes.
Mm-hmm.
Do you guys think that similar across different games?
So the question is, we, as a Blizzard gamers, there are several people that play multiple games, and whether we capture the performance in some other game and possibly initialize the skill or determine the skill in the other games. Currently, we don't, and that's actually a good thing for us to think about. What we do though is, like, when people switch from one game mode to the other, we use the performance in a particular game mode to inform how they should be seeded, how their skill should be set. But we haven't really thought through in terms of, well, if we know about your WoW history, how can we inform your hero's performance from that?
Okay. I think we only have time for one more question. Sorry.
A rather controversial topic. Blizzard constantly adjusts the attributes and abilities of the specific numeric attributes of characters and avatars and aspects of the game. Every time they release a patch, they adjust these things. There's controversy. How much of that is quantitative data driven? How much of that is just qualitative inference by some expert?
So the question is, Blizzard does regular patches and tweaks the characters and their abilities and does these balance changes, and they tend to cause friction for certain subset of our players. And the question is, how data driven is it or qualitative is it? And so we track a lot of metrics from all these heroes and all the players, and we also look at what stage the players are in. Are they new players, or are they coming back after a long gap? Are they high skill players? All of these things. And we look at all these evaluation metrics, and that in association with community feedback. So sometimes, even though we feel internally that it's reasonably balanced, if there might be cases where community feels strongly, then we would address the community's concerns. So it works both ways, but we do track a lot of these things and try to make data-informed decisions.
All right, let's take the rest of the questions offline. Thanks, Chaitanya, again.
Thank you.